Hey everyone, thank you for joining. Today we're going to look at Azure AI Model Router, specifically when dynamic model selection actually makes sense and when it doesn't. So a little bit about me. My name is Ramin Ahmadi. I'm a developer architect at Advania UK. Focus on Azure AI, Microsoft 365 SharePoint, and all Microsoft-related technologies. I build AI-powered Microsoft 365 solutions, and I've been contributing to the PMP community with samples, scripts, and as a speaker. I write blog posts covering AI, Azure, M365, and SharePoint. So feel free to check out my blog and follow me on Twitter, GitHub, and Twitter. First, here's basically what we will cover in the next 15 minutes. First, we will look at my why using one model for everything is a problem. Then I will explain what model router actually is, the architecture, the 18 models available, and the routing modes. Then the fun part, I will switch to the Azure portal and show you how to deploy it live. After that, we will walk through my .NET code and run it against 4 different scenarios to watch the router make real-time decisions. And finally, the stuff I wish someone told me before I ship this to production, gotchas, lessons learned, and key takeaways. So let's dive in. So here's the problem we all face. How many times you've ever asked yourself, which model should I use for this? Look at these 3 scenarios. If someone asks what is 2 plus 2 and you route that to GPT 4.1, you're spending 50 times more than you need to. That's like booking a private jet to go across the street. Flip side, someone uploads a 40-page contract for analysis and you route it to GPT 4.1 Nano. You will get garbage, too weak for that task. And third one is the sneaky one, complex supply chain optimization routed to GPT-4 or Mini. It will give you an answer, but it won't reason through the constraints properly. So the real cost here isn't just money, it's maintenance. If you try to build routing logic yourself, you're writing a classifier, maintaining a model mapping table, and updating it every time Microsoft drops a new model. That's a nightmare. But what if Azure could just pick the right model for each query automatically? That's exactly what Model Router does. So let's look at this flow. Your app makes one API call, the exact same chat completions API you already use. That call goes to your Model Router deployment. The router evaluates the complexity of the prompt and picks the best model from a pool of 18 available models, then returns a response. And here's the key part. In the response, the model field tells you which model was actually selected, so you always know what happened behind the scenes. And if we look at these numbers, we have 18 models in the pool. We have 3 routing modes: quality, cost, and balance, which I will cover in next slides. And we have 1 API endpoint and 0 code changes. If you're already using Azure OpenAI, you literally just change the deployment name, same SDK, same code, and that's it. So let me break down what's in the pool. The November 2024 version includes 18 models across 5 categories. At the lightweight end, we have GPT 4.1 Nano, Mini, GPT 4 or Mini. Those can handle simple Q&A for fraction of a cent. In the middle, we have GPT 4.1, GPT 4, GPT 5 chat for general analysis and content generation. And for complex reasoning, we have O4 Mini and GPT-5 reasoning models. And here's a big update. So multi-provider support is a new update. Cloud, Haiku, Sonnet, and Opus from Anthropic, Grok 4 from XAI, DeepSync, and Llama from Meta. This is no longer just OpenAI. It's a true multi-provider routing layer. The November release also added custom deploy with routing modes, model subnet selection, agentic scenario support, and the reasoning effort parameter, which I will cover in the demo. As I mentioned, there are three routing modes. We have quality, which routes more queries to powerful models. Use this when accuracy is non-negotiable, like medical, legal, financial. We have balance mode, which is a default selection, and where I recommend you to start. That's the sweet spot between cost and quality for most applications. And finally, we have the cost mode, which aggressively routes to nano and mini. Only complex prompts get escalated, and it's perfect for high volume chatbots and customer support. So my advice is to start with balance, measure it for 2 weeks, and then decide where to go from that. All right, let me show you how to actually set this up. I'm going to switch to Azure Portal. Okay, here I am in Azure Portal. This is my Microsoft Foundry project. Make sure you switch to this new UI, because if you're using the classic UI, you won't be able to customize this model, and you have to go with the default option, which is balanced, and is going to use all of those 18 models available. But if you need to customize it, make sure you switch to the new Foundry UI. And from here, we go to the browse models, and we're going to search for model router. There you go. This is the model router. You can see the description. These are the available models in the recent version. So you have two options here. You can go with the default settings, which going to be the balance mode with all of these available models in the pool. But if you want to customize it, you can just go here. So you can see you can select your routing mode. Default is balanced, but you can go with quality or cost. You can select your version, and also you can tell it to use all the available models, or you can just select the subset of models. So for example, you can select only GPT-5 models, or you can exclude some of these models from this deployment. And then finally, you can just deploy it. Because I've already done that, to save some time, I'm going to escape this. All right, let me switch to Visual Studio now. Okay, this is a .NET Console app, nothing fancy, intentionally simple, so we can focus on the model router integration. Starting with program.cs, the entry point. Here is the standard .NET configuration. We are loading from app settings and user secrets. This is where our Azure endpoint, API key, and deployment name live. Nothing model router specific here. Same config you would use for any Azure OpenAI project. Then we bind the config to an Azure OpenAI config object. Again, totally standard. And here, where it gets interesting, we create the Azure OpenAI client with our endpoint and API key credential. This is identical to what you would write for any Azure OpenAI app, and there's nothing new here. And here's where the magic happens. So see this second parameter? That's the name of our model router deployment in Azure AI Foundry, and that's it. That's the entire integration. Instead of passing GPT-4 or GPT-4o, we pass the model router deployment name, same client, same SDK, same everything, just a different deployment name. We also pass in the telemetry service. I will show you why that's critical in a moment. I've set up 4 scenarios, as I mentioned, basically to show how the router behaves. Scenario 1, simple questions. We expect the router to pick nano or mini for this kind of questions. Scenario 2, information lookup. This need more knowledge, but are in complex reasoning. We expect mini or a standard model. Scenario 3, that's a document analysis. I'm simulating a contract review, key dates, financial terms, risk factors, and obligations. This should trigger a standard or reasoning model. and scenario 4, which is a complex multi-step reasoning. So here we have three products line, revenue constraints, profit margins, market saturation percentage. So this is a proper optimization problem. We expect O4 mini or GPT-5 reasoning here. And we have the run scenario method. For each query, it calls process query async, then prints the model that was used, token count, cost duration, and a preview of the response. This is what we will see in the console when we run it. And just right at the bottom, we have display summary. After all scenarios run, this pulls the telemetry data and prints a full summary, like total queries, total cost, and estimated savings compared to a static GPT-4. This is the money slide in the console output. Now let's look at query service. This is where the actual API calls happen, and this is the file I want you to pay the most attention to. First, the constructor. We take in Azure OpenAI client, the model router deployment name, and this telemetry service. This creates the chat client pointing at our model router deployment. Again, this is the exact same get chat client call you would make for any Azure OpenAI deployment. The SDK doesn't know or care that it's a model router behind the scenes. Now the process query async method, this is core of the app. Let me walk you through that. So we capture the start time for duration tracking, and then we build our messages, a system prompt, and the user query, a standard chat completions pattern. We then we set the max token output, temperature, and reasoning effort level. These are passed through to whatever model the router selects. And important note here, if the router selects a reasoning model, like O4 mini, for example, the temperature parameter gets ignored. And also reasoning models don't use temperature. So bear that in mind. And the actual API call, standard complete chat async, no special method, no router specific API. The routing happens server side, completely transparent to your code. And results, the actual response text, normal. This is the most important line in the entire code base. The model property in the response tell you which model the router actually selected. So when you send a query, you don't know upfront whether it's go to Nano, Mini, GPT 4.1, or Mini, but the response tells you, and this is your window into what the router is doing. So yeah, input tokens, output tokens, total tokens, standard usage data, estimated cost, and this is where it gets interesting. If you go to the cost calculate cost method, because different models have wildly different pricing, you can't just use a flat rate. Look at the switch expression here. So nano models is like 0.15 dollar per million input tokens, basically free. Mini models, there are 0.30 per million, and GPT 4.1 is around $5 per million. That's 33 times more than nano. Telemetry service, that's the last file. So this is the simplest one, but it's what ties everything together. Now get summary method. This is what generates the console output at the end of the demo. Count of everything we processed, sum of all estimated costs across all queries, total tokens consumed, and average response time in milliseconds. And get all results, return the raw list of raw list if you need to just do further analysis. And that's the whole thing. Three files, the Azure OpenAI SDK does the heavy lifting, Model Router does the routing, and your telemetry captures everything you need to validate it's working. So let's run the code. And what I want you to watch is the model use line for each query. You will see it changes as the query gets more complex. So for scenario 1 questions, you can see it used GPT-5 Nano and O4 Mini. For scenario 2 query, it used GPT-5 chat, and for scenario 3, it should use GPT-5 or GPT-4 or Mini. Let's see, because it's a complex query, it's going to take more time. Yep, it's done, and you can see it's used GPT-5 for this. And the last one, which is a complex multi-step reasoning, are expected to use GPT-5 again, or one of the reasoning model available in the pool. And after this, we're gonna see a summary. Okay, yeah, it's done. So for the last one, again, it's used GPT-5 because it needed a reasoning model. So here you can see a summary. So this is the total cost, average cost per query, average duration, but this is the cost saving it that we can see. So if you wanted to do the same with the static GPT-4, this is the cost for you. So here we saved around like 37 for 4%, and sometimes it goes even higher to like 15%, 60%, what we saw in our production. So that's a lot of savings here. Okay, let me go back to my slides. So let me put real numbers on this. So 55% average cost reduction versus a static GPT-4, and over 50% latency reduction on simple queries because Nano is blazing fast. 18 model options, auto-selected, 0 code changes, and the bar chart tells you the story. So static GPT-4, $13 per 1,000 queries. Model router in balanced mode is $13.50. And for the cost mode is around $80. $8, sorry. That's real money at the scale. And they do not show you why 40% of queries go to the cheapest model. The router is smart about not overspending. Okay, what went wrong? This is the basically our experience with production deployment. Number one, context window trap. This is the biggest gotcha. Router may select Nano for a large document. Nano has a smaller context window, as you know, so instant failure. Same document works next time because a different model gets selected. So intermediate failures are the worst kind. Our fix, we estimated the token count before sending. If it's over 20K tokens, bypass the router entirely and use a static GPT 4.1 deployment. Number two, quick vs custom deploy. Quick deploy gives you zero control. So fix balance mode, all 18 models. If you want to choose your routing mode or exclude certain models, you need to use custom deploy. Number three, no telemetry, called flying blind. Always log completion.value.model, always, because we wasted 2 weeks debugging before adding this. And number four, agent service limitation. When using model router with agent service tools, only OpenAI models get selected. So Cloud, Grok, Llama won't participate. Bear that in mind. And the pro tip, build a hybrid approach. Model router for general queries and static deployments for tasks where you know the requirements upfront. Thank you. That's Azure AI Model Router in 15 minutes, what it is and how to deploy it, real code, real results. All the links are here, my blog, the Microsoft Docs, the code sample. I've written 2 deep dive blog posts on this topic, and thank you so much for your time.